torque. Just as forces on a body affect its translational motion, forces change a rotating body's motion as well. In rotational motion, the magnitude and direction of the applied force are important, just as in translational motion. Additionally, in rotational motion, the point of application of the force is important as well. For example, a force applied at the end of a tire iron is more effective at loosening a bolt than the same force applied at the end of a short wrench. You see in our diagram, FB will be more effective than FA. This quantity that measures the tendency of a force to cause a change in a body's rotational motion is called torque. In this figure, we are shown a method of how to calculate torque. Torque is given by the symbol tau, and it's equal to the force times the lever arm. The body in this example rotates about an axis that is perpendicular to the plane of the figure and passes through the point 0. These three forces act on the body in the plane of the figure. The tendency of the first of these forces, F1, to cause a rotation about O depends on its magnitude. It also depends on the perpendicular distance, L1, between point O and the line of action of F1. In force 2, the line of action passes through the point of rotation, so its lever arm is 0, and hence the torque is 0. It is important to note that torque is always measured about a point. It's always measured with reference to some specific point. If we shift the position of this point, the torque may shift as well. This diagram shows how to calculate the magnitude of the torque. Find the lever arm L and use tau equals FL. Determine the angle phi between the vectors R and F. The lever arm is R sine phi. So tau, the magnitude of the torque, equals the magnitude of the force times the magnitude of the radius, the distance between where the force is applied and the rotation axis, times sine of phi, the angle between R and F. In the last slide, we saw how to calculate the magnitude of the torque. But we must note that torque is a vector. The magnitude is the vector product R cross F. The torque vector is equal to the vector from the axis of rotation to where F acts and the force vector F.